All right, you're on.
Okay, so today we're going to talk about retinoscopy. Retinoscopy 101, as I called it. So the most important resource, honestly, like I was telling everyone a little bit earlier, is you really can teach yourself retinoscopy with the help of Tim Root's video Retinoscopy, 2 parts, 1 and 2. So once we watch that, then you can watch it on your after. But basically, retinoscopy is an objective measurement of the optical power of the eye, or how somebody is focusing. It is the most objective measurement, and what's nice is you can use this objective measurement. So, we have the AR, you have a patient's last glasses prescription. Your retinoscopy can also be a starting point for your manifest refraction. And if you're a good retinoscopist, then you should be pretty close, and you shouldn't have to do much refinement once you have done your retinoscopy. Retinoscopy can be super, super quick if your patient is cooperative and if you're not in the PEDS clinic. So basically what happens is the retinoscope illuminates the inside of the eye, and we observe the light and how it's reflected. Once light falls to the back part of the retina, you see a certain reflex, and it's called neutralization, so the eye fills with light. That is the goal. So we'll kind of go through how the retinoscope works, the different types of retinoscopes, the reflexes that you'll see, and then we'll watch the Tim Root video. If we have time, we'll practice today. If not, we'll do another time where we can just do total hands-on skills. So who should you retinoscope when you are learning? Everybody. I don't care if you even just put a patient in the room who's dilated, it's obviously easier on a dilated patient. They're not going to be focusing and they'll have a much bigger pupil. If you put a patient in the room for a doctor, just pull out the retinoscope and just get used to looking at reflexes. That's how you're going to get to learn. The more you do it, the better you'll get at it. But realistically, who really needs retinoscopy would be somebody where there's a communication barrier. So children, somebody who's disabled, maybe somebody who is deaf. We had a patient who had a stroke and who couldn't speak anymore. That would be a good patient to retinoscope. Maybe we have a new patient, can't get him into the AR, doesn't have glasses. That would be a good patient. So anywhere where you need a starting point or where you cannot communicate with somebody, that is who is a great person to retinoscope. Even if you're trying to manifest somebody and they are just taking you, Curtis, we were just talking about this, they take you all around the block for their astigmatism. You can easily find the astigmatism axis. You don't even have to, don't worry about finding the sphere, don't worry about finding the power, but if you can just pull out the retinoscope and see exactly where that axis is, then you shouldn't have to go far from there.
That's cool.
Yeah. So there's a couple different types of retinoscopes. There's a lot of different types of retinoscopes. I was scoping a little boy the other day and he's like, that looks ancient. And because I was putting the handouts together for this, the first retinoscope was actually from 1873. So it really is ancient. It's stood the test of time. But so you'll see on the left-hand side, the Copeland retinoscope. It's older. I do not like it. The reflex isn't as bright. To turn down, you kind of have to pull down. I just didn't learn on it. I learned on the Welsh Allen. I think the Welsh Allen is easier to learn on because the light's much crisper. And to me, it's a little bit easier to use. So how it works, there's a light source. The bulb is in here. There is a condensing lens that focuses the light rays. There's a mirror that projects it forward. We have the focusing sleeve. And we'll talk a little bit about sleeves in a second, but the focusing sleeve, it rotates, so you can literally change the meridian of your light rays. And then we have the battery source, which is in here, and then coming from our slit lamps, which help recharge it. Moving forward. So when you are handling the retinoscope, it's important to keep both eyes open. And we have to be, ambidextrous. It's really important to try and use both hands and try to not only use your dominant hand. And when you are retinoscoping a patient, when you're retinoscoping their right eye, you're going to have both of your eyes open, and you're going to have the retinoscope on your right eye, and you're going to be scoping their right eye. When you scope their left eye, you then come to the left side. You are going to use your left hand, your left eye, and scoping their left eye. Unless they're cyclopleged. If they are fully cyclopleged, then it doesn't matter. You can just be right in front of them, having them look right at you. We have the patient focusing in the distance at the biggest target. You do not want them accommodating at all, because when a patient accommodates, what's actually happening in the eye is your lens is constantly changing shape, right? So if your lens is changing shape, guess what? The light rays or the reflex that you see in that eye is going to be ever changing. That's why we have to have kids cycloplegic when we do their cycloplegic refraction. Same thing for adults. I mean, obviously for older, if they've had cataract surgery, that's not a big concern. But if they're 45, you know, they can still focus just fine. Then you'll just kind of have this ever-changing reflex. So focusing on something further in the distance. Even if your head's in the way, just instruct them, pretend like my head's not here and just keep looking straight ahead. So maintaining a working distance. The working distance is a distance from the patient's eye, or from the lens that we have in front of their eye, to my eye, or my retinoscope. Typically the average is about a diopter and a half. And so we get this from good old optics, D equals 1 over F. The distance equals 1 over the focal length. So the average is about 150 because we're about 66 or 1/3 of a meter away. If you have longer arms, then you should take off less. If you have shorter arms, you should take off more. And this all goes into that focal distance. But what you can do is when you start, measure your arm length so you can exactly figure out where you're at. Mine's a little bit weird. I must sit really far back. I have to take off 1 diopter. That doesn't make sense because my arms are very, very short. So I think I'm just like really far back from the patient. So you really do need to take that into account. So the sleeve, it can rotate around, but it also moves up and down. And the moving up and down changes the way the light inside the retinoscope focuses. And it's different from the Welsh Allen to the Copeland. For the Welsh Allen, we want it in what we call the plane mirror, which means there's no focusing of the light rays, and that's sleeve down. So always sleeve down with this one. With the Copeland, it's going to always be sleeve up. Unless you're doing some fancy estimation tricks or honing in on your axis, but for right now, just, that's like a whole nother talk. So sleeve down. And then as you spin, let's see, is it dark enough in here? Well, you can kind of see it on here. When you rotate this, that light spins. So when you start refracting, or when you start scoping somebody, when you have the light rays horizontal, you move it up and down to see the reflex. When you have it vertically, you move it side to side. And what you're going to be looking for is certain reflexes, or same thing, you know, if you have it, let's see, obliquely, you're going to move it this way, so you're kind of always moving it in the opposite direction of where you have your light source. So there's a picture on here. You're going to see different reflexes. They're kind of self-explanatory. With movement, when I'm shining my flashlight, when I'm shining my retinoscope at the patient's eye, I work with kids too much, let's see your flashlight. As I move it, the reflex is going to go with my retinoscope. For against, as I'm shining it, I move my retinoscope one way, the reflex is going to go in the opposite direction. These are really important because when you see with motion, you add plus to neutralize it, or to get the light to fill the pupil. If you see against motion, you add minus. But what's super important is when you're retinoscoping, you always want to be in with motion. So if you see against motion, you add a lot of minus to get you back into with motion, and then you start cutting the minus. That'll make sense in a second, I promise. Neutralization, so that's once we have found the perfect prescription, that light rays is sitting in the back part of the eye and the retina, and that is what that patient needs. If everything's all intact, the brain's working well, there's no issues, that's what they need to see perfectly. There's also something called scissoring. I saw a lot of this when I was training. The residents would always just write scissoring. That meant they couldn't get it and the reflex was funky. But scissoring is a thing, so what happens is you're not seeing a nice one reflex, you're seeing a couple reflexes kind of coming together. So that could be from a couple different things. You could have a distorted cornea or an irregular cornea. They could just have really large pupils, and sometimes you see this with the little ones when they're so dilated, you get a nice crisp line and then a couple on the side, and you're like, wait a minute, there should only be one. You just focus on that center. You pick one and you focus on that one, because there's no way that you can neutralize both those lines. So there's 3 major characteristics of your reflex. The speed. The slower the movement, the further you are from neutralization. The quicker the movement, the closer you're getting. Brilliance, the duller the reflex, the further away. The brighter it gets, the closer you are. So if you ever pull a retinoscope, and if you're looking at a patient and you just see a really dull reflex, what I see you do is you throw up a +5 and you throw up a -5, because that'll get you more in the direction of where you need to go if it's super dull. You're like, I don't even know what I'm seeing, with or against. Throw up a big plus, throw up a big minus, and then you'll be like, oh, the plus, it's getting brighter, I'm gonna keep going that way. Or if you throw up the -5 and it seems to be getting closer, then go even further until you see a nice crisp reflex. So getting started, we want to begin with width in all of the meridians. And this will make more sense too once you start watching Tim Root. So the hardest thing about teaching retinoscopy is I can't show you what I'm seeing, and you can't show me what you're seeing. So Tim Root has some really nice animations of like what you will see. It obviously looks very different on the inside of the eye, but you'll be able to appreciate that motion. So if you see against motion, against means add minus to get through neutralization. We're going to add even more minus. So that way we have to start adding more plus or less minus to get to work to neutralization. If you go in the opposite order, 1, it's confusing when you're first starting to learn, and 2, your prescription, we tend to overdo it when we go from plus to minus. So always working in more plus, you'll be more accurate that way. Spherical eyes and astigmatic eyes are different. Obviously, a spherical eye is going to be much easier. When you start to look at a patient, what I always do is I always check 180 and then I check 90. And you see, as you're starting to add plus, to make sure, is it all neutralizing the same? If I hold up a +3 and the eye fills with light, and no matter where I turn this, the eye is nice and full of light, that means it's a spherical eye. There's no astigmatism. But if I'm scoping somebody, and I kind of tried to make some, where is it? Oh, here's my pictures. Oh, so you can tell I made these ones. So you see how in that first picture, the little circle, it's at 180, and that's my filled pupil. And then I turned it to 90, and now I'm still seeing with movement. That would be a good example of, all right, here is some astigmatism at 90 degrees. Or in the second picture, it can also be oblique. So I've filled the pupil with light at 45, now I've turned it to 135, and now there's still movement. So wherever you filled the pupil, 90 degrees away from that should be your astigmatism. It's super important to note the lens that you filled your first meridian, because that is going to be your sphere. Then once you've turned it 90 degrees away, you're going to continue to add plus until the eye fills with light. And it's the difference between those two lenses that is what the cylinder power is. And then it's that second meridian of where your retinoscope is at, that's the astigmatism axis. So there's a little example here. Let's say with the +250 lens in front of the eye, I've neutralized it at 180. And now I turn my retinoscope and I'm checking, and oh, there's still with motion at 90 degrees. So I keep adding plus until I now see that meridian fill with light. And I've had to go to a +450. So we know the astigmatism is at 90 degrees. And the difference between the +250 and the +450 is 2. So there's 2 diopters a cylinder. But then we have to make sure we take away our working distance. We take away the working distance only from the sphere. And we take away that working distance because the patient, I am 1/3 of a meter away. I'm not 6 meters away at optical infinity. So that's where that working distance comes in. So I have to take away about 150 from my sphere. So if I neutralize it with the 250, I take away 150 from that, and it's a +1. So your final prescription would be +1, +2 at 90. Yeah. So a couple of things can happen when you're trying to find that astigmatism, and there's a nice picture here, and this is pretty much what it looks like. If you're nice in line with that astigmatism, you'll see your line, you'll see your reflex around the eye, but then you'll see the reflex in the eye that's perfectly parallel to your light. If you're a little bit off axis with your cylinder, you'll see exactly what this looks like in that first picture. You'll see your line and then the line inside the pupils, just like a little cattywampus. You have to line your retinoscope up to match that line. So my tips, always, always, always work in with motion. Don't try to go backwards because then you just get confused with your lenses, what came first, what was the cylinder power. It's always best to just bring yourself into the more minus and slowly add plus. When I first bring out the retinoscope, I typically check the main axes of 180 or 0, 45, 90, and 135 to see if my reflexes look different. A lot of times, the duller the reflex, the higher the prescription. If I check 180 and I have a nice bright reflex, and then I don't even have a lens up, and then if I flip it to 190 and it's really dull, I automatically know that I need to neutralize my 180, and then I know my astigmatism is going to be at 90. And you just keep adding. Dull reflex, I talked a little bit about this. You're going to throw up a +5 and a -5 and see which one starts to look brighter or more crisp, and then you keep going. Don't forget to take off your working distance, and that's only from the sphere. And if you see scissoring, try to just realign it or focus on its center. And if a patient's not dilated, try to control their accommodation with the big working targets. You can absolutely retinoscope undilated pupils. It's a little bit harder, obviously, because you have much, you can't see as much of the surrounding reflex, but you can totally do it. They just have to keep looking straight ahead or kind of beyond your head. Let's watch some Tim Root. Tim Root Retinoscopy parts 1 and 2.